Hello, this is page 4 of quadratics. Today we're going to be drawing some parabolas with characters that they give us. I don't think you'll find this too difficult. First one, number 1. A parabola with vertex 1, -3 and x-intercepts at -1 and -3. Let's try to draw that. First of all, I'm going to draw my axis lines. Remember on the exam that you should label the axes. I'm not going to always do that on the video, but you should always do it on an exam and in a lab report or an IA. Okay, I'm going to draw my parabola in blue. And I see that it has x-intercepts -1 and 3, so I'm going to label those points with dots. And it has a vertex at 1, -3. Okay, so I think I can already draw it through these points, and since I only have these 3 points, the rest of the points aren't going to be like super exact unless I figure out what the equation is and graph it in the calculator. But it didn't ask us to do that, so we're not going to do that right now. Okay, so it will look kind of like that. We know it goes up, right, because the vertex was below the x-axis. Since the vertex was below the x-axis, it needs to open up. Let's do this one where the vertex is -1, 2, and the range is y is less than or equal to 2. What does that mean when the range is y is less than or equal to 2? Well, first of all, we already know that the y-coordinate of the vertex was 2, so we knew that the range would be either y is greater than or equal to or y is less than or equal to 2, because the parabola has to open up or open down. But if it's y is less than or equal to 2, that means it opens down, right? Because it goes below y equals 2. So let's draw our grid lines first. Oops, that wasn't very good. Okay, and then we'll draw the points -1, 2, which is our vertex. And we know that the range is y is less than or equal to 2. So we know that it's going to go open down. So it would look kind of like this, okay? If you want to draw a pretty accurate parabola, you could use the typical points, which are 1, 1, 2, 4, 3, 9, right? So let's go 1, 1, 2, 2, 4, and 3, 9, okay? So those are the typical points for a parabola. Which parabola is that? Well, it's the parabola that has the a value equal to 1. Remember the a value? So we don't know, in this case, what the a value is. So you don't have to draw it through these points, but if you do draw it through these points, it is a parabola with an a value of 1. Now in this case, it is an a value of -1, right? Because it's going down. It opens down. And it opens down because the range is below 2. So numbers like 0, -5, -7, those are all numbers below 2, right? What about in the past we've had ranges where we say y is less than 2. Why is this one y is less than or equal to 2? Well, this is because it includes the vertex in the range, right? Okay, moving on. Number 3. A parabola with an axis of symmetry at x equals 0 and a range less than or equal to -1. Okay, so let's draw our grid. And we're going to draw some points. Ooh, x equals 0. So this doesn't give us a point. It gives us the axis of symmetry, which is along the y-axis because x equals 0. The range, it says, is less than or equal to -1, which means the vertex is something, comma, -1. Something, comma, -1 would be along the axis of symmetry and -1. So that's our vertex right there. And does it open up or down? Well, it says y is less than or equal to -1, so that means it opens down, right? So we could put some points here, like that, and then we could draw a parabola that has a equals -1. Okay. All right, so we drew the axis symmetry at x equals 0. We drew the vertex at something -1. It happens to be 0, -1, because the axis symmetry is at 0. And it opens down because it says range is less than or equal to -1. Okay, let's do the next one. So number 4, a parabola with x-intercepts 3 and 0 and range that is less than or equal to 1. So why don't you go ahead and try to do this one without watching the video, and then just come back and check your answer. Okay, you're back. So the x-intercept is going to be here and here, 3 and 0. And the range is less than or equal to 1. So let's see, less than or equal to 1, it would be somewhere, the vertex is going to be somewhere on this line. And you're like, well, how am I supposed to figure out where it is? You didn't tell me where it was. Is it here? Is it here? Is it here? Okay, well, it turns out that the axis of symmetry tells you where the vertex is going to be in the sideways direction. It will be exactly in between these two x-intercepts, right? Because the x-intercepts are at the same height. The parabola has to be in the exact middle of those 2 points, right? So it's going to be somewhere here. And we know that it's at height y equals 1. So we know that the vertex is going to be here. And we know that it opens down because 2 reasons. One is they tell us the range is less than or equal to 1, so it opens down. The other reason is we know that the x-intercepts are at 0 and 3, so it also must open down. Oops. That's not a very good picture, but you get how it is, okay? And I'm going to erase this line so you don't think that that's something that's part of the parabola. All right, last 2 problems here. So, number 5, a parabola passing through points 0, -2 and 4, -2. So 0, -2 would be here. 4, -2 would be here, with a maximum value at y equals 2. Okay, and so actually we know that those 2 points are there too because the proportion 0, 0, 1, 1, 2, 4, but you don't have to do that. And then we are going to, okay, so the maximum value is y equals 2. We knew that the maximum value is at y equals 2. And we knew that the point that goes to the points 0, -2 and 4, -2, which are those 2 points. Okay? So we knew that the vertex is halfway in between these 2 points because these 2 points are at the exact same height. And we know that the parabola is symmetric. Remember that word from the investigation? Both sides are the same, like a mirror image. Okay, number 6, a quadratic function. Okay, try to do these on your own before you watch me do them, okay? These are like little puzzles. Quadratic function, which is the same thing as a parabola, that takes a negative value between x equals 2 and x equals 5 and f0 equals 4. Okay, let's do f0 equals 4 first. What the heck does that mean? This is from the last unit. We talked about function notation. One of these numbers, 0 and 4, is x, and one of them is y. So with this notation, this value is x, and this value is y. Okay, the x is the input to the function f, and y is the output. So 0, 4 would be this point here, right? 0, 4, because actually f0 equals 4 is another way of saying it goes to the point 0, 4. Wouldn't it be easier if they just told us that? The function takes negative values between x equals 2 and x equals 5. So x equals 2 is here, x equals 5 is here, and it says that the quadratic function takes negative values between x equals 2 and x equals 5. So that means that it is somewhere in this region. The quadratic function is in this region between 2 and 5. Okay, and so that means it's in the positive region here, right? And here too. Okay, so how can we draw a parabola that is in all the yellow regions? So you can see that it necessarily crosses, it has to cross the x-axis at these 2 points that it gave us. So it kind of looks like this, right? And it also needs to go to this point on the y-axis that we specified. So it's kind of gonna look like that, right? All right, and that was a pretty tricky one. That was the last one.